Welcome to the webcast, Best Practices for High-Strength Steel Repairs. This webcast will provide a high-level overview of vehicle construction, how to identify the characteristics of certain steels, where they are commonly located, and to what extent they can be repaired. For more in-depth content on the best practices for high-strength steel repairs, ICAR now offers a live training class, which launched yesterday. Today's presentation will be led by Jeff Poole, Performance Training Coordinator at ICAR, the leader in collision industry training. I'm Bruce Adams, Managing Editor of ABRN, and I'll be the moderator. We'd like to thank our sponsor, Caroliner, for bringing this webcast to you free of charge. Please note that at the end of today's presentation, there will be time for a question and answer session where you can submit written questions. Now let's get started. Jeff, can you please briefly address ICAR's vision and mission?
Thank you, Bruce. The ICAR vision is that every person in the collision repair industry, current and future, has the necessary knowledge and skills relevant to their position to achieve a complete and safe repair. ICAR was formed by the collision industry in 1979. The ICAR Inter-Industry Conference on Auto Collision Repair is an international not-for-profit training organization. It's important to keep in mind that all ICAR activities and resources focus on helping the collision repair industry achieve a high level of technical training. ICAR develops and delivers technical training programs to professionals in all areas of the collision repair industry. Ultimately, our mission is that ICAR will be the leader in research, development, and delivery of quality, convenient, cost-effective educational programs for the collision repair industry. Moving on to the next slide there. As we take a look at ICAR and what ICAR is made up of, it really is a cross-section of the industry: collision repairers, insurers, vehicle manufacturers, educational institutions, parts and material suppliers, tools and equipment suppliers, and other related businesses. It takes all of these segments coming together in order to take and guide ICAR, give us the feedback and the input we need. It also takes a tremendous network of volunteers and instructors out in the industry that make it possible for ICAR to provide training to the industry.
Thank you, Jeff. Now I would like to ask the audience a polling question that they can respond to online. Their responses will be tabulated and presented to all viewers. The question we'd like you to ask is, how many in the audience have taken ICAR training? Please select one of these answers. I've taken ICAR training in the last year. I've taken ICAR training in the last 2 to 5 years. I've trained with ICAR more than 5 years ago, or I've never taken any ICAR training. Again, please pick one of those four responses to the question, how many in the audience have taken ICAR training? Last year, 2 to 5 years, more than 5 years ago, or I've never taken any ICAR training. Okay. We can see from these results that more than almost 60% have taken it in the last year, 21% 2 to 5 years, and only 8% have not taken any at all. Thank you very much for polling in with these responses. Jeff, can you review some of the recent events in the industry that have got us to where we are now?
Absolutely. The key influences are corporate average fuel economy and safety. These factors are really driving the vehicle manufacturers to utilize the most advanced materials and manufacturing processes in the build of vehicles. Ultimately, this equates to changes in repair considerations for the collision repair industry and changes to some of our process procedures as we repair those vehicles. We look at those material content changes, the roof cross regulations, and the advanced OEM manufacturing processes such as laser welding, MIG Brazing, and other things of that nature. As we take a look at keeping up with the latest technologies, it's really critical that we as the repair industry, the repair professionals, we're aware of the advanced material contents, the advanced high-strength steels, the different aluminum contents that might be out there, some of the plastics and other items along those lines, along with the technologies The vehicles really are a concert as they go down the road, and we need to make sure that everybody's playing to the same tune, that the structure of that vehicle is going to perform properly, and that the technologies on that vehicle are going to perform properly. So as an industry, we're kind of at a crossroads where we need to kind of make that decision to keep up, and that's what we're trying to do as an industry, is keep up with new repairs, new techniques that need to be followed to maintain the safety of the vehicle. As we take and we look at some of the older techniques that we've used to repair vehicles in the past that may have been acceptable on those older vehicles, but with today's vehicles, we need to make sure that we're doing correct procedures so that we're maintaining that 5-star crash test rating. And that vehicle comes in, and it was originally a 5-star crash test rated vehicle. We have to ask ourselves the question, will it still be that 5-star crash test rated vehicle after we've repaired that vehicle?
Can you tell us a little bit about how ICAR developed this high-strength steel repair course?
As we take a look at some of the new vehicle structures, the steels used to construct modern vehicles are driving our industry to evolve our repair methods. We have a lot of conversations with folks in the industry about, can we weld steel? Well, certainly we can weld steel. But the real question becomes, what happens to that steel when we weld it? And how is it going to then potentially perform in the future? So we look to the industry for guidance on course topics. We're always looking to get that input. Through our network of advisory committees, we identified a need to address the challenges the evolving steel content is having on estimating and repair, and that's what's brought us to this point. As we take a look at the ICAR Repairability Summit. We conducted a ICAR Repairability Summit in May of 2011. And the real purpose of this Repairability Summit was to take and get representatives from the industry together, vehicle manufacturers, equipment and tool makers, insurance representatives, and collision repair professionals, as well as representatives from Automotive Steel Association and other interested individuals. We had discussions that covered the changes to vehicle construction and the steel content, how the vehicle reacts in a collision, and the forces that are involved there, as well as structural repair considerations, part removal, and attachment methods. We used 2 different generations of the same vehicle, utilized as a representative example, where we had an 08 Malibu and then an earlier model year vehicle of the same type, Malibu, and ultimately we were using that as our case study, if you will, because we have a dramatic change in the amount of high-strength and ultra-high-strength steel between those 2 model years. The ICAR Repairability Summit, as a result of this, the culmination of that is the SPS 09 course. Basically, this course, we take a look at many of the topics that we're going to discuss here today on the webcast. We have a much more comprehensive view of each of these topics in the course itself.
Can you address some of the basic science behind high-strength steel repairs?
It's critical. As collision repair professionals, we really should understand how the repairs we perform on the vehicle are going to affect that vehicle's integrity and performance. Our work may be put to the ultimate test whenever that consumer takes that vehicle and gets in a collision. We don't really want that to happen. We hope nobody goes out and gets injured or hurt severely or killed. But we really have to ask ourselves those hard questions. How is the repaired structure of this vehicle going to perform? How did my work affect how that vehicle is going to perform in another collision? How's the repair process going to affect this? So it's real common for us now to see steel strengths expressed in a term called Mega Pascals in vehicle material identification diagrams. And just to kind of put this in perspective so that we've got kind of a baseline there, this is a unit of strength of a material, and so a megapascal is 1 million pascals. Mild steel is typically in the 200 megapascal range, just as kind of a reference, which is about 29,000 psi. We have steels out there, ultra-high-strength steels that exceed 1,300 megapascals, which is equivalent to about 188,500 psi in the body structure. And again, to kind of bring that around and have an understanding, a comparative understanding, typically with our MIG Welding machines that are out there, we're using ER70S-6, which is about 70,000 psi or about 485 megapascals. We have to then weigh that in mentally into the repair process of, okay, whenever I cut something and I weld it back together, where is it really at? Where's the performance of that part going to be? Again, we have to look at the heat effect zone near that immediate weld site. So these are the things we have to think about during the repair process on that vehicle. We see dramatic changes in the performance characteristics depending on the material that we're welding and the technique that we use. So these are all things that we have to think about as collision repair professionals.
So with all of these different types of steels found in a single vehicle, it's more important now than ever that repairers know the type of steel they're working on.
Absolutely. As we estimate and repair vehicles, it is more important than ever to identify what we're dealing with so we can make the right decisions, we can make the correct decisions regarding repairability. The real key here is that so many of the generalizations we've dealt with in the past, we can't really apply universally. So there may be considerations that we need to take a look into on account based on perhaps some specialized tools or equipment or fixtures that may be required as part of that repair. We may find that in the repair process there are some rivet or adhesive or rivet bonding or some other specific equipment requirements or tool requirements that may be unique to a particular vehicle, and it's really going to be critical to identify that early on to ask ourselves the questions, do we have the right tools, the right equipment, the right training in place so that we can properly facilitate this repair and put a safe vehicle back on the road. As we continue on, we take a look at some of the OEM terminology. There are various names that the vehicle manufacturers associate with their steels. They're not all the same strength. And again, there tends to be some gray area out there. Some classify ultra-high strength steels as 600 megapascals and above, or they may call it a very high strength steel. Others may say that ultra-high strength steel is 700 megapascals and above, where others may reach up towards 800 or 980 megapascals as the ultra-high strength steel threshold. A few have compiled charts listing the different types of steels and what repairs can be done on each type of steel, including heating and straightening and attachment methods. As part of the SPS 09 course, one of the handouts that the students get to take away is a compilation of some different repair guidelines that various different vehicle manufacturers have based on the strengths of those steels and what's appropriate so far as welding and heating and straightening techniques and things of that nature. So that's a very valuable component of that particular course. There does tend to be some consensus from the majority of vehicle makers that start to list the ultra-high strength steels as 600 megapascals and up. Again, there's still some gray area in there, though, that we have to be cautious of. The best way as we move forward to identify the material that's in the vehicle structure, of course, is always going to be the OEM service information. This has been a resource that has gotten better over time. We're seeing where the availability is a whole lot more prevalent than what we had in the past, and that continues to move forward. If we cannot locate any information on the composition of the steel, what's the next best thing we could do? Well, there is hardness testing equipment we'll take a look at and discuss that very briefly. And then we look at some not-so-scientific methods of identifying what we're dealing with, so far as drill tests and solve tests and things of that nature. Location and function is typically going to be a real good indicator of what we're dealing with. So many of the vehicle manufacturers, they've got that 5-star frontal and that 5-star side impact crash test rating, and ultimately there tends to be a common underlying theme there. Where we're seeing that 5-star, we're seeing a similar use of materials, not saying that everybody uses exactly the same composition of steel in those reinforcement locations and things of that nature, but it's a good bet. When they've got that 5-star side impact crash test rating, they've got some extremely high-strength steel or ultra-high strength steel more commonly in that rocker panel reinforcement and that B-pillar reinforcement. So taking a look at the location of a component, a reinforcement, is a good indicator of what we're dealing with. Exterior body panels are typically not ultra-high strength steel, but on occasion we may come across some high-strength steel for some dent resistance. There may be some exceptions. Of course, most of the industry is aware that Volvo uses some ultra-high strength steel on some of their outer lower rear body panels, and they do have some procedures that associate with those components. As we continue on into 14, primary structural members on the vehicle is where we usually see the ultra-high strength steels and high-strength steels. We're seeing the ultra-high strength steels in the bumper reinforcements. We see a lot of the dual-phase steels for frame rails. And the advantage there for the vehicle manufacturer, of course, is the energy absorption capability of that material. We have trade-offs, though, where we get better performance, crash performance, and occupant protection performance. We don't necessarily get more repairability. The work hardening component of these steels tends to drive these parts to challenge us in the repair process, and we find that in some cases they're cracking and tearing in the repair process more so than in the past. Ultra-high strength steel is becoming very predominant in the B-pillar and rocker panel reinforcements, as well as some of the A-pillar reinforcements that are out there. We may find that there's different steel strengths used on the inner rail versus the outer portion of the same rail. And it may also have some hidden reinforcements that in some cases stretch up into the ultra-high strength steel realm as you move further back towards the passenger cabin. All of this affects the repairability of these components. Again, different strengths of steel may respond differently in the structural realignment process. So as we're pulling, we may find that we've got some steels that are cooperating and coming around, and we've got other components that, of course, are not, and we may have to look at other repair considerations or replacement considerations at that point. Taking a look at hardness testing, there's a couple of companies out there that are producing hardness testing equipment available to the collision repair industry. If we don't have service information that directly dictates and speaks to the material composition that's in the vehicle, this is a more scientific way of doing it versus, I want to say, less scientific methods like a drill or a saw test. So with this equipment, we can at least identify the strength of the steel, puts it into a reasonable strength category range. It's not going to tell us the exact chemical composition. It's not going to tell us perhaps if it's a boron alloy steel or not, but it will tell us approximately where we're falling, and it'll help us make better decisions on what we should do in the repair of that part. So this is a step in the right direction.
Jeff, what are some of the basic indicators of steel hardness that repairers should be looking at?
So many times as collision repair technicians find out, they're out there drilling a quarter panel off, they're drilling a rocker, an outer aperture, a uniside off of a vehicle or whatever it happens to be, and they're drilling along and they're making real good progress, and then they come across a couple of spot welds that seem to be going into a reinforcement, and next thing you know, they've smoked their drill bit. They've dulled the edge on it, and you know, that's one of those low-tech type of, we learned it the hard way, and many of us do that on a regular basis. Again, that's telling us that we're drilling into something that's harder than our standard spot weld drill, and we're dealing with a pretty tough opponent at this point in time. So the drill bit test is kind of a non-scientific. We definitely want to make sure that we identify the need for any specialty drill bits and things of that nature as early on as possible to keep production going and minimize wasted efforts and equipment. The saw test is another, I want to say, non-scientific. If you take a pretty traditional reciprocating saw blade that is designed for metal, and we're finding that we can cut through certain components on the vehicle pretty readily with this. Once in a while, though, we're going to come across something that we start cutting into, and the teeth just start coming off of that blade or getting flattened. And again, we know we're up against a pretty tough opponent at that point in time, and it's a good bet that we're dealing with some form of an ultra-high strength steel. There are some specialty blades that are designed for ultra-high strength steel that will take and go on a reciprocating saw that will definitely cut through that material. But again, we need to make sure that we've identified the correct blade for that application.
So how does all this affect the repairability of high-strength steel?
For many years, we've discussed the kink versus bend rule, and there's been a lot of industry discussion around that. So we're going to take a look at the kink versus bend rule and its applicability. Generally, the rule still applies to steels that are below 600 megapascals. That statement needs to be qualified. We need to inspect any structural components when we're repairing this vehicle for any signs of permanent deformation, which may not come out. And if we're pulling a structural component and we get it to pull back to dimension, but we don't have the shape of that part back correctly, it's not repaired. And at that point in time, we have to make that decision on what we're going to do. If we can't get it back to its prior condition, then we've got some considerations there we need to look at. So we need to inspect for any signs of permanent deformation that may not come out, as well as any cracking or tearing which may be present in collision damaged structure. The composition of many of today's steels lend themselves to micro cracking, which may not be evident to the naked eye. There are some recommendations out there that we see for dye penetrant testing of areas that have been damaged and repaired. Again, the work hardening exponent, as I touched on earlier, the rate of work hardening on many of these advanced high-strength steels is substantially higher than what we've dealt with in the past. I can personally recall situations where I straightened some things that were pretty severely bent. They were mild steel and relatively cooperative. And then there was a point in time where I was pulling on some structural component on a later model vehicle where it was a high-strength steel or some other blend of steel, and the damage wasn't that bad, but yet it wouldn't pull out. And we were using pretty much all of our resources to try to get that part to straighten out. So this is a factor of the work hardening rate, and it's in the makeup, the composition of the steel. This translates to the steel getting brittle when it's damaged, and increasing the potential for cracking and tearing during repair attempts. And at that point in time, we're looking at some sort of a part replacement procedure or part sectioning procedure. Generally, if the strength is higher than 600 megapascals, we're going to find that we've got some severe challenges in front of us with parts cracking and tearing. There may also be situations where damage to other parts of the vehicle occurs as we've got higher strength materials attaching to adjacent lower strength components further into that vehicle structure potentially. And it really depends on, again, the engineering design of that vehicle. We're finding that we have limitations on heating allowances from the vehicle manufacturer. That's nothing new. It's kind of interesting to take a look at some of the metal repairability matrix that are out there and the allowances that are still out there as permissible. And definitely, if we've got the allowance and we can use heat, use it where it's applicable, but make sure we follow the guidelines and recommendations. Generally, we don't heat steels that are over 600 megapascals, and for the most part, the ultra-high strength steels, they're generally not repaired if damaged. So this is something that we delve into much deeper in the SPS 09 course. As we transition forward, we take a look at some of the part removal considerations. Again, this is something that we're still going to use many of the same tools and some of the same basic concepts that we've used in it, but it's a matter of technique is really what it comes down to. So we're going to take a look at some of the technique. Many of us will be using tools that we're familiar with on slide 20 there. Whether we drill it or are we using a cutoff wheel or whatever it happens to be. It's going to be important that when we're drilling, we drill at low speed and we use a lubricant. Definitely, if you have the ability to drill it and drill from the softer metal into the harder metal, drill that softer metal. Bits designed for ultra-high strength steel need to be used at low speed, and extreme care must also be exercised to keep the bit square to the work to minimize the possible of chipping or breaking the bit. It's a bad time to sneeze whenever you're using one of those spot weld drills. It's a pretty substantial investment. The laser weld removal tools that we see in the upper right-hand photo helps control the depth of cut as we remove laser welds. We need to maintain the flange integrity of the underlying structure of that vehicle. Our repairs, in my mind, need to get more surgical and more precise in our preparation, and that starts at the beginning of the repair where we're disassembling that vehicle and we're taking the right steps up front to make sure that we're prepping the flanges adequately for the installation process that comes later. In some cases, a plasma arc cutter may be called for in the removal of some components or may be used. We have to be real careful. Plasma arc cutters do have a very minimal heat effect zone. However, there's quite a bit of heat still being dissipated behind that arc. And I know some of the equipment that's available have very precise adjustments that you can tune it down to cut through one layer of metal. But we also need, again, just to be aware of the potential heat effect of any underlying panels or components that might be there. So this takes, in my mind, experience and the right equipment in order to do this correctly with a plasma cutter. Our friend the cutoff wheel, the grinder, it's still a real good choice for grinding welds and cutting through high-strength and ultra-high-strength steels and things of that nature. It's definitely one of those staple tools that will probably be around for quite some time.
Now let's talk a little bit about structural repairs in three-dimensional measuring systems?
An important part of a complete and safe repair is ensuring the structural repairs are completed correctly. This requires appropriate training and the right structural repair equipment, along with the capability to measure the vehicle three-dimensionally. What we're doing when we're repairing a vehicle is we get that damaged vehicle that comes into our facility, we measure it. That way we know where it is. And comparing that to our dimensions that are in that measuring database, we know where we're at and we know where we're going. So we're creating that roadmap of the repair as we measure the damaged vehicle. We know where we're at, we know where we're going. There's no guesswork. This is what we need to do. We're going to identify the damaged areas, direct and indirect damage, and in so many cases on these later model vehicles, those indirect damage indicators aren't as visual. They aren't as blatant as what we've seen in the past. So we're seeing in some cases where we've got some pretty subtle indicators that may not jump out at you that we may miss if we don't measure that vehicle thoroughly. So this is where it's critical to measure that vehicle. We also need to take a look at that dimensional situation with that vehicle to understand where are we going to anchor and how are we going to pull this vehicle. So as we're looking at the vehicle with our visual clues, we're also taking and building that plan off of that measuring system. Some of the materials in the vehicle structure we may find pull easier or harder than other areas. Then, again, depends on the strength of that particular part. And we may find that some areas will provide better anchoring than others, and these are all some additional topics that we'll discuss deeper in the course. The direction of the pull is also something we need to take into account because ultimately that will have an influence on how we anchor that vehicle, again, as we look at this as a more surgical operation.
Now I would like to ask the audience to answer a second polling question. Does your shop own a three-dimensional measuring system? Please select one of the following responses. Yes, we own one. Yes, we own more than one. No, our shop doesn't own any, or I don't work in a shop. Once again, that's does your shop own a three-dimensional measuring system? Yes, we own one. Yes, we own more than one. No, or I don't work in a shop. Okay, I guess we just had the yes or no choice there. 63% yes, 36% no. Thanks for polling in with your responses. Moving on. Jeff, can you tell us how does high-strength steel impact side collision repairs?
With the increased use of ultra-high-strength steel that we're seeing in the passenger cabin reinforcements, particularly the rocker panel reinforcements and the B-pillar reinforcements, we're seeing a certain decrease in the repairability of these materials, which drives us to either a partial or a complete replacement. In many cases, this increases the intrusiveness of the repair. Again, what we have to take in mind is that side impact scenario where potentially you've got a vehicle hitting that vehicle in the side at some point in the future. And you have to ask yourself that question. After you've repaired that vehicle, do you want to be behind that B-pillar? Do you want to be inside of that vehicle on the side that you've repaired when somebody's hitting you in the side at 30, 40, or 50 miles an hour? That's a scary proposition. I've had customers ask me that, Jeff, would you trust this vehicle in another collision? And I tell them yes, absolutely. So we find that in some cases sectioning may be limited on some of these parts, again, based on the material content on the part makeup. We need to be sure that we're keeping an eye on the vehicle dimensions on these vehicles as well. We may not see the severity of the compromise of the centerline misalignment of the front and rear sections to that center section, but it does still happen and it needs to be corrected. Again, contingent on severity of collision and vehicle design and other factors as well. But it's critical that we're measuring these vehicles over their entire length to ensure that we're correcting that center line, we're correcting that center section, and we're getting those structural components repaired properly. That photograph that's on the slide right now, it really, again, speaks volumes about what it takes to correctly address some of the side structural repairs on many of today's modern vehicles.
What types of attachment methods will we be seeing in the repair process compared to the OEM?
That's something that, again, we need to ask ourselves early on in the repair process. We need to ask some critical questions, and this is one of them where we say, okay, how am I putting the panels back on? And so I can identify the best way for me to take them off and prep the flanges. So again, squeeze-type resistant spot welding is a predominant leader out there from the vehicle manufacturers in the build process. We may see a little bit of MIG welding and MIG brazing, and of course we do see some weld bonding. We're starting to see some incidents of rivet bonding in the repair process as well. So we're going to break each one of these down just a little bit as we move forward, slide by slide. We're finding that squeeze-type resistant spot welding is really the popular recommendation as we take and put the vehicle back together, moving ahead. The vehicle manufacturers utilize it predominantly, and we find that in many cases they've got very specific recommendations. It's interesting as I look through some of the different information resources that are out there, and I look at some of the OEM repair recommendations, and this is where this particular course, SPS 09 Best Practices for High-Strength Steel, really takes and we look back over where we had general sectioning guidelines in the past, and that was applicable to mild steel. And so we find that general sectioning guidelines aren't so applicable today. So we move forward to say, well, follow the vehicle manufacturer's recommendations. Well, that's great. If we've got those available, and we definitely want you to access those, let's do that. But what if there aren't any procedures out there? What are the best practices? And that's what we look at here as okay, predominantly what do we see out there from the vehicle manufacturers as recommendations? Therefore, whenever I'm working on a vehicle that perhaps there aren't any recommendations, these would be the recommended best practices as we take that step forward. At a certain point in time as an industry, we have to make those educated business decisions. We want to make the best ones we can under the circumstances. So with squeeze-type resistant spot welding, we're finding that is the #1 contender in many of the repair scenarios. What we have to watch for here with squeeze-type resistant spot welding, though, is that we have to take into consideration the material stack that we're dealing with. We may be dealing with an ultra-high-strength steel, a high-strength steel, and a mild steel in that same material stack. And so the setup and the operation of that equipment is critical, that we've got the right equipment and it's being used properly so that whenever we do those squeeze-type resistant spot welds, #1, we've placed them properly, and #2, we've got the right integrity in that weld whenever it's done. We're testing those welds out ahead of time. So again, squeeze-type resistant spot welding is a very popular process over there. Generally, we don't place the squeeze-type resistant spot welds in the service procedure or the part replacement procedure over existing weld locations, but we may find there are exceptions to this due to the design of parts on the vehicle, or we may have an alternative replacement procedure that's called for.
Now I would like to ask the audience to participate in our third and final polling question. How many shops use STRSW resistance welders? Please select one of the following responses. Yes, we use them. No, we don't. Or I don't work in a shop. Once again, how many shops use STRSW resistance welders? Please respond by selecting either yes, no, or I don't work in a shop. And it looks like 25% of the shops there are using them, 12% are not, and balance do not work in a shop. Thank you for participating in our third and final polling question. Jeff, can you talk a little bit about the difference between MIG welding and MIG brazing?
MIG welding during the repair should be taken into consideration. We have to kind of weigh in the potential damage from the heat from the MIG welding process. We still have a tremendous amount of applicability of the MIG welding process. And again, just to clarify, MIG welding being we're joining, in this case, the context of the conversation, we're joining steel with steel. And that's where we really have to think about what's our electrode wire that we're using, what's the potential heat effect, are we using the correct shielding gas, and ultimately during that repair process, if we're using MIG welding, we need to really focus on what techniques can we use to minimize our heat effect. And yet at the same time, we want to make sure that we're getting good weld penetration, that we're getting a good sound weld on that vehicle. So again, it becomes critical in setting up and tuning that welder and using it on that vehicle that we've got the applicability to the repair being undertaken. It's critical that we do test welds, that we're dialing that machine in. In some cases we find that, and I'm guilty of this, I'm guilty of sometimes of tuning that machine up to where it's a hot weld because I know I'm getting good penetration, but I'm potentially, I want to say, doing more damage than good there because I've got such a hot weld. I've got the machine tuned up too hot. So again, taking the time as we get ready to weld on that vehicle becomes critical to get our equipment dialed in. Contrast that to MIG Brazing. MIG Brazing is a lower temperature MIG process. So with MIG Brazing, we're finding the vehicle manufacturers are using this in key areas. There's substantially less damage to the parent metal strength and the corrosion protection. The slide on the screen of the MIG Brazing slots does a real good job of exemplifying the fact that it requires a bigger footprint of material go down. This is something that we don't see in a lot of repair procedures at this point in time. We're seeing it called for periodically, and perhaps we'll see this become more embraced in the future. What we would like to see is ultimately that the collision repair industry, whenever we potentially see this become more prevalent, is ready for it, that there's no questions about how do I do this. It's not a difficult process. It's a little bit different from MIG welding steel. It takes a little bit of getting used to, but typically using a silicone bronze wire, and there may be a specific alloy of wire that a vehicle manufacturer might call for, but using a silicone bronze wire and argon shielding gas, some of our traditional MIG welding machines will facilitate this operation. There are some machines out there that are set up with special programming to really help that process and make it go a little smoother.
Can you share with us the results of an industry study that sheds some light on the importance of proper repairs?
Sure. A research project was carried out by KTI in Germany. It shows in a nutshell that improperly repairing collision damage, especially in newer vehicles constructed with these higher tech materials, leads to an unsafe vehicle and subsequent collisions. Essentially, a vehicle repaired using traditional repair materials and equipment and techniques that we had used of about 10 years ago. I drive a vehicle that's 10 years old. The specific results of the study showed that whenever that vehicle that was repaired using those older techniques was then crashed again, they did a crash test on it, there was an additional, more than additional 2 inches of intrusion into the passenger compartment. This increased damage to the adjacent sections of the vehicle, and it also resulted in the failure of the side curtain airbag. That's kind of scary. So what they also did, well, is they took a similar vehicle, and they repaired it using the correct repair procedures for that vehicle. And then they crashed it, and they found that, again, similar crash test type scenario, they found that that vehicle, when repaired properly, held up. It performed properly. Everything worked the way it should. So, again, this is where we have to really stop and ask the questions when we're repairing these vehicles today. Can I keep applying what I did yesterday or the day before or last year or 10 years ago? Or should I look at updating my procedures and techniques? Sectioning a B-pillar used to be an approved procedure on the Chevy Malibu. But, as of the 08 model year and moving forward, we're finding that that's no longer acceptable. There's a whole host of other examples out there that we run into on a daily basis. Again, we're hopeful that folks are asking the right questions up front and not asking the wrong questions later.
Today's repairs have much tighter tolerances than in the past. Jeff, can you talk about what that means to the customer and the repair?
It's definitely placing greater challenges on the repair industry. The dimensional tolerances that we've been seeing over the past year is getting tighter and tighter. We've got vehicles with a millimeter, a half a millimeter, close to zero tolerance out there that we're having to repair, and ultimately what that drives is us needing to repair to that exacting tolerance as well. We want that vehicle to perform properly in that next collision so that customer will come back and see us again, and we'll get to repair that vehicle again, hopefully. Again, all of this drives us to a more exacting repair, which, again, requires the right tools, training, and equipment. industry leaders have provided information to ICAR as we continue along. We've gotten feedback that the benefits of ICAR training and ICAR Gold Class professionals results in higher quality, safer repairs. Ultimately, we've seen reductions in cycle time. We've seen increases in productivity and efficiency. The bottom line is for our customers, it's a better customer experience. When they come and they get their vehicle and everything's right the first time, and again, they'll take and spread the word that we've done a good repair on their vehicle. We also know that contrasting where there's challenges and customers have issues with vehicles, that they tend to spread the news also, and that's probably not so good for business. So we want everybody to have a positive experience out there, and we feel that through training and professional development, that is the ultimate goal, and that'll help us meet our vision. The SPS 09 course is a course that is designed for new technology for the estimator, non-structural technician, auto physical damage appraiser. It's also applicable to the steel structural technician at Pro Level 3. If you've never attended an ICAR class before, this is a great class to begin with. If you've been away from ICAR for a little while, it's also a real good course to get your feet wet with.
Thank you, Jeff. We'd like to take this opportunity to solicit questions from our viewers. If you have a question to ask, simply type it up and send it to us through the channel provided. Some of you have not wasted any time in doing that, and we've already got our first few questions in. Jeff, the first question for you is, how can I identify if a structural part can be sectioned?
ICAR gets a tremendous number of technical inquiries on a daily basis, and what we've actually done is we've put together a selection of top technical inquiries on the ICAR website. There's a main menu there that drops down on technical information links. And definitely, so far as identifying structural parts and sectioning, the collision repair information from the vehicle manufacturer should be your number one resource. Sometimes, though, there's no recommendations from the vehicle maker. So in this instance, it becomes a business decision between the insurer, the vehicle owner, and the repairer as to how the vehicle is going to be repaired. There are a tremendous number of considerations that go into that thought process. You know, what's the composition of this part, and what's the function of this part, and again, how does it tie in with the adjacent structure of the vehicle? So ICAR has also another resource on the website. It's a partial replacement recommendations matrix. We highly recommend, it's a free resource, we highly recommend folks take and reference that matrix that helps to identify OEM-approved partial replacement recommendations for some of the common repair areas that we deal with.
Are we seeing any significant trends toward using high-strength steels in auto skins rather than structural components?
You know, I don't have the numbers in front of me right now, so I really can't put a solid answer on that. I know that we've definitely seen, you know, an increase in the use of bake hardened steels and things of that nature over what we dealt with in the past, so that they can get those skins down to a thinner gauge of steel and keep the body components as light as possible. But you know, to say it's significant, I don't know the numbers to speak to that, so it's difficult for me to give that a straight answer.
Can outer skin high-strength steel panels be repaired, such as door panels?
That really depends on the severity of the damage and you know, the nature of the technique that's being used on those components. Again, that's a pretty broad spectrum question, and you know, it's a case-by-case basis where we have to evaluate the severity of the damage and see how it's responding. You know, for me to make a blanket statement that says yes you can or no you can't, that's a tough one.
Have recommendations been developed, and if so, what are the recommendations for using used high-strength steel parts?
That's a business decision along the way. ICAR does not delve into the areas of parts sourcing so far as that goes. That's not an area that we're going to touch so far as that goes. You know, it is a business decision. What we have to do is we have to step back and we have to really look at the function of that component, And, are we going to be able to remove it from that recycled component adequately? Are we then going to be able to install it using the correct installation procedures into that vehicle structure properly and come up with the right end result? So that's something that would have to be navigated very delicately.
Can high-strength steel skin panels be repaired via PDR, paintless dent removal?
There are folks out there that are doing it. Again, contingent on the severity of the damage, the accessibility to that area, obviously the condition of the paint and things of that nature. There are folks out there that are successfully doing PDR on some of these panels.
What was the highest number on MPA steel that could be repaired?
There's a threshold of about 600 megapascals that we're finding is about the threshold on repairability. But what we have to really look at is what's the damage. Again, putting it into context with what's the damage. Do we have a rail that maybe has a little bit of sway in it, and we're just going to take and we're going to pull the sway out, and there's no real physical hard buckles in it? Or are we dealing with a rail that or a structural component that we've actually got physical buckles in it, and we're finding that getting those physical buckles out is a very challenging task. So there are some considerations in there, but the threshold that we're seeing is about 600 megapascals where we've got any real involved damage.
If a high-strength steel panel is repairable, does it take longer to repair than a normal steel panel?
I will not answer that question here.
Okay. When should a structural part be repaired or replaced?
When should a structural part be repaired or replaced? That's a real good question there as well. And that's one that in deciding whether to repair or replace it, we really need to take and go down through kind of a mental thought process. We look at that kink versus bend that we touched on. A bend is defined as a change in the shape of the part between the damaged and undamaged area that's smooth and continuous. When the part's straightened, it's returned to its proper shape without any signs of permanent deformation. That's the tricky part. Kink tends to be 90 degrees or greater over a short distance, usually a small radius. So typically if we've got something that's kinked, we start to pull it and try to straighten it. There's a permanent area of deformation, and again, we may be dealing with a bent part that due to its strength and its composition, we can't get it to straighten out. So where we've got permanent damage that can't be repaired regardless of the type of repair being performed, we're starting to look at parts that need to be replaced. Some additional considerations, again, the extent of the damage, the location. Is it an area that's subject to repeated stress? What type of surface is it? Is it an engineered shape or a flat surface or a corner? We look at proper restoration of corrosion protection and of course restoration of part dimension.
Is all straightening done cold only with no heat?
For the most part, what we look at on steel is the initial attempts. We put some corrective force on there, and we see how it responds. And if we're finding that it's not responsive, then we then identify if there are heating allowances for that particular makeup of metal, that part, that metallurgy, and then we move forward from there. So no, not all vehicle manufacturers allow heat. There are some that basically say cold straighten or replace, and I definitely recommend sticking to that from a liability stance and a prudent judgment stance.
What is the recommended gas mixture for MIG welding and ultra-high strength steel? The same as always?
The recommendations we're seeing from most of the vehicle manufacturers is still a 75-25, 75% argon, 25% CO2. That's not to say that there might not be some unique recommendations out there from some vehicle manufacturers, and I would definitely recommend investigating on a case-by-case basis what you're dealing with. But to this point in time, we haven't seen a tremendous shift away from that.
Is there any likelihood of returning to brass oxygas process instead of MIG brazing?
I doubt it. The heat The heat migration using oxyacetylene torch welding is so much greater. And that's the real key with the MIG Brazing process, is that it's much more focused and the heat migration is so much lower. So I don't believe we're going to see any real shift back towards oxyacetylene brazing.
There's a question here asking if engine cradles can be repaired.
Generally, they're not. That's engine cross member, suspension cross member. Generally, they're not. But again, that's a very wide open question. What's the damage to it? Does it just have a little scratch or a scrape, or is it something more involved? So it's really difficult to pin that one down without knowing more of the facts and figures behind the scene.
If you cannot duplicate laser welding, what do you do?
Again, that's an area where we're seeing some vehicle manufacturers have specific recommendations to come in and use resistance welding to reinstall the panel. There are other recommendations out there to, in some cases, do some slot welds along the panel edges. We may find that there are still other recommendations that vary out from there. What I've really tried to do is step back and start to ask the right questions up front with all the repairs. What am I dealing with, and what do I need to know so far as part replacement on here? What's acceptable during that repair process, so that we can formulate that better up front as an industry. That's going to be critical to coming up with the right end result on each repair.
Are even stronger steels on the way in the future? And if so, how will that change the repair equipment required?
Wow, that's a good one. And it scares me a little bit to think of what we're dealing with now compared to what we dealt with 10 years ago and 20 years ago. I'm pretty confident they're formulating things right now for us to have interesting challenges with in the future. I don't have my crystal ball in front of me. If I did, I'd be, I want to say, looking for a lot of other answers in the world as well. But it'll be interesting to see where we go. Again, education, keeping up with it. What we develop today is something that we're always thinking about. What are we going to take and bring to the classroom tomorrow? We're working on courses today that will help us today and tomorrow. And we're going to continue to strive and move forward as ICAR to take and develop what do we need to know for tomorrow. That's what we're always trying to work with the vehicle manufacturers on and work with the other industry segments on, and so that we can help you all as an industry make the best decisions possible.
Other than ICAR's website, is there one single website that has most of the manufacturers' recommendations on repair processes?
I believe it's OEM One Stop that has links to. I'm not sure if I don't have that right in front of me right now, but that's a pretty easy one to look up. There's also the National Automotive Service Task Force. Their website is a real good resource. There's a tremendous number of them out there, and it's interesting what pops up whenever you do a Google search.
If a recycled assembly is proper, how do we identify that the metal stack is the same that we are replacing?
That's a real good question, and that's something where we have to be cautious of what's the build date. Did the vehicle manufacturer change something in the production process, part model year? And really the only way that we would know that is to resource the specific service information for that particular vehicle. That could be a challenging proposition, but it's a good consideration.
How will high-strength steel be used going forward to meet current and future fuel standards?
Well, the trend has been set, and it's been happening for a number of years now, where we've seen that gradual increase, and it's just continued to evolve in that direction. I think that we're going to see that continued migration to more high-strength steel and less mild steel, so that they can take the gauge thickness down and maintain the crashworthiness of the vehicle. I think we're going to continue to see implementation of ultra-high-strength steels, strategically in that vehicle structure so they can, again, minimize weight. And we can still have all of our technology on board, because there tends to be that offset there as well, where we take and we minimize the build in the structure so far as the weight goes with the right materials in the right locations to get that crash performance and that safety performance. We want all that technology, and all that technology adds up to weight going back into the vehicle. The vehicle manufacturers have done a tremendous job with the drivetrain development and the fuel economy that they're getting out of these vehicles today, especially considering some of the performance levels. They're pretty impressive.
Should adhesive be used to replace corrosion resistance in joints to be welded? Frequently, we see a foam-looking product and or adhesive in these joints.
Yeah, the vehicle manufacturers use various different sealants or adhesives. In some cases, they're just sealants. In other cases, they may be structural adhesives. And this really does become another one of those case-by-case situations as to, number one, we do want to look at OEM guidelines on how they want us to put the vehicle back together. They may have recommendations to use weld bonding techniques. They may have recommendations to not use the adhesive and double up on the number of welds or some other procedure. We're seeing some situations where panels that are welded using squeeze-type resistant spot welding in the manufacture of the vehicle, they're calling for rivet bonding procedures to put those panels back on and getting away from welding altogether. So it's really an interesting mix out there. Again, it becomes a situation where if we don't have recommendations available from a vehicle manufacturer, we have to make our prudent decisions in how we're going to repair that vehicle. So hopefully we identify what those materials are. In many cases, it's a best practice to take and duplicate the original installation if we don't have specific recommendations otherwise from an OEM.
Is MIG welding okay to use for ultra-high strength steel?
That depends on what you're going to do with it, the location, the application. Again, it becomes a very specific question. I always ask a couple basic things whenever somebody asks me a question like that. What's the make, model, year, and what's the damage to the vehicle? What are we doing to it? And then I help navigate through some of those decisions that we have to make. We may find in some situations it is acceptable. We may find in other situations there are very specific recommendations to put a particular reinforcement in, maybe using strategically resistance welding in certain locations, adhesive bonding in another location within the same reinforcement, and MIG welding very strategically at other locations within that same reinforcement installation. So again, it in some cases becomes very critical that we're doing our homework ahead of time.
Thank you, Jeff, for presenting this information. And once again, thanks to our sponsor, Caroliner, for their support. If you'd like to view this webcast again or share it with somebody who was unable to participate today, the webcast will soon be archived at www.abrn.com/high-strength-steel. Once again, that's www.abrn.com/high-strength-steel.